You see robots everywhere, right? But have you ever really stopped to think about what makes them move? I'm not talking about the computer brain or the fancy sensors. I'm talking about the hidden muscles doing all the real work. That's what we're diving into today, the unsung heroes of robotics, actuators. I mean, seriously, how do they do it? How does a robot go from a line of code to actually walking or flying or putting a car together with that insane precision? What's the secret sauce that turns a command into real physical action? Well, it's not magic, but it is a brilliant piece of engineering at the heart of every single moving machine. And that secret sauce? It's the actuator. The absolute best way to think about it is like this. An actuator is the muscle of a robot. You know, if the sensors are the eyes and the computer is the brain, the actuators are what actually get things done, turning those digital commands into motion in the real world. Seriously, without them, even the smartest robot on the planet is just a really expensive statue. Okay, so let's get into it. We'll start with the most common type you'll find, the one that's all about precision and fine control, the electric actuator. The idea here is pretty straightforward, but it's also super powerful. Electric actuators just take electricity and use a motor to create motion. You know, spinning something or pushing something. But their real superpower, it's control. They're incredibly efficient, and you can adjust them with like microscopic precision. Now, there's a trade-off, of course. They're not usually the strongest kid on the block. But for any job where accuracy is the name of the game, they are the undisputed king. And trust me, you see these things everywhere. Next time you see a video of a car factory, look at those robotic arms moving with that insane pinpoint accuracy. Yep, those are powered by electric actuators. It's the same tech in the complex joints of a humanoid robot trying to walk, or even in the propellers on a drone that are making thousands of tiny adjustments every second just to stay stable. It's all about that fine control. But, okay, what if you don't need surgical precision? What if what you really need is just raw, unstoppable power? Well, that's when we say goodbye to the world of electricity and step into the realm of pure brute force, hydraulic actuators. So instead of electricity, hydraulic systems use a pressurized fluid, usually some kind of oil, to create movement. By forcing this fluid through cylinders and pistons, they can generate an absolutely immense amount of force. The downside, yeah, these systems can be a bit complex, maybe a little slower to respond than electric ones. And, well, let's just say a fluid leak can get pretty messy. But when you absolutely positively have to move something incredibly heavy, nothing else even comes close. And this is really where they shine, in jobs that would be completely impossible for other types of actuators. I want you to picture a construction robot just effortlessly lifting massive steel beams into place. Or think about a search and rescue bot that needs a hydraulic claw to literally tear through concrete rubble. That's where you need that raw, unstoppable power. All right, so we've covered precision and we've covered power. But what if the job calls for something different? What if a robot needs to be gentle? What if it needs a more flexible, almost biological kind of touch? For that, we need to talk about pneumatic actuators. The secret ingredient here is compressed air. Seriously. By controlling the flow of this air, pneumatic systems create a motion that's remarkably smooth and forgiving. Now, the trade-off is that air, it can be squished, it's compressible. That makes them less precise than electric motors and definitely less powerful than hydraulics. But that very same squishiness is what gives them their gentle, compliant nature. I mean, think about it, right? You would not want a super powerful hydraulic arm performing surgery on you. No way. But a pneumatic tool? It can provide that exact, delicate touch that's needed. We see this in agriculture, too, with grippers that can pick a delicate raspberry without turning it into mush. And it's also key to the whole fascinating field of soft robotics, where the goal is to make robots that bend and flex just like living things. Okay, let's do a quick recap. On one hand, you've got clean, super precise electricity for that factory arm, but you're limited on strength. Then you've got the immense raw power from pressurized fluid for the construction bot, even if it's a bit messy and maybe not the quickest. And finally, you have that gentle, flexible touch of compressed air for something like a medical gripper, where you're trading raw power for safety and a soft touch. See? Each one is the perfect tool for a totally different job. But what if you need something else? What if you need the incredible precision of an electric motor, but in a package the size of a single muscle fiber? Or what if you want motion with no motor at all? This is where the future starts to get really interesting. Because those three plastic types we just talked about, they are just the beginning. Take, for example, something called shape memory alloys. These are metals that literally remember a shape and snap back to it when you heat them up. It's an incredible way to create silent muscle-like motion, especially in tiny microrobots. And then there's piezoelectric actuators. These are special materials that expand or contract when you apply a little bit of electricity. This allows for the kind of mind-boggling precision you need to, say, operate an electron microscope. Just wild stuff. So here's the big takeaway. It really doesn't matter if we're talking about a giant industrial machine or a microscopic little bot. Actuators are that fundamental link. They're the bridge between a robot's brain and its ability to actually do something in the world. They are the magic ingredient that transforms a static hunk of metal into a dynamic, functional system. And that really leaves us with one final, exciting question to think about. As these robotic muscles keep getting stronger, more precise, and even smarter, what new abilities are we going to unlock? What incredible challenges will these machines help us solve next? Honestly, the possibilities are just incredible to think about. Thanks for joining me for this one.